After adding the material stream, now it's time to add the unit operation. The unit operations is the equipment or the tools that we are going to use to do a specific function. Like if we start here we have a model palette, we can make it disappear by pressing F4 or appear by pressing F4 again. Okay, so here I have displayed all. You can again view the model palette unit operation by this one listed and has a description, or just this one, a simple view. Okay, so now I am going to check all, and here we have a mixer, we have a T, we have a heat exchanger. The simplest one is adding a mixer. A mixer is usually added to mix two streams together. So if you don't know the description, simple. Press here, and this is combine multiple inlet streams to produce one single outlet. So now if I have these two streams, natural gas feed and water, and I want to mix them together, because if we are simulating a natural gas coming from a well, it's usually saturated with the water. So we can have the natural gas feed in containing all the hydrocarbons, and we have another water stream describing the water inside the well, and we can mix them together to have something like the actual feed. Okay, so now I have two feeds, which is natural gas feed and water. You can just press on the unit operation and throw it to the point that you want it to be added. Okay, so now we have our mixer, which is our first unit operation to add. To open the mixer, you can just double click on it. After double click, it will appear like this one. Okay, what is important here is to know that inside this course we are going to start from the design, which is the simplest one, creating a steady state by connecting the unit operation to the inlet and the outlet and adding the conditions. Okay, so this is the simplest one. The advanced one is doing the sizing or the rating. So the sizing, the design here will be the simplest one. The rating is a little bit advanced. For the worksheet here, the data will be printed, and the most advanced is having the dynamic one, the dynamic or a real-time plan. So during this the session, instead of describing all the steady state of all the unit operation and then start again for all the unit operation again to be advanced or dynamic, I'm going to do something different. I will be describing a mixer from being a steady state or a simple steady state to the maximum, which is being running dynamically. Okay, so let's take it step by step. So this one has a code of mix 100. You can name it a mixer and give it the code of the unit. Okay, and this is the first step to do. So now it is named a mixer. The mixer can has different inlet streams. So in this case, I have the natural gas feed, and I'm going to mix it with the water stream. So here I have natural gas feed and a water stream, and I'm having a message appearing. Okay, the error here is coming from, so I'm going to close this one, and I am having a stream cutter over here. Why I'm having a stream cutter? Because it is mentioning here the transition not ready. Okay, maybe this one is running. Okay, so I'm going to remove this cutter. Water cutter can be deleted because the stream have different fluid package. Okay, so now I understand where is the error coming from. For the natural gas feed over here, the fluid package is NG, natural gas. For the water, if I open this one, the fluid package is the basis. So the first thing to know is if we are creating a mixer, I'm going to mix two streams, make sure that they are on the same fluid package. So in this case, I'm going to open here, and I am going to delete the water stream. So now my mixer is only and all here for this one. The cutter, I'm going to remove the cutter. Okay, for this one, for the mixer, I am going to create another material stream for the water, okay, to be mixed. But this time I am going to use the right fluid package, which is the natural gas. So this is the fluid package, which is natural gas. So I'm going to press F11, and this one will be water to mixer, and this water to mixer is at the temperature 25 as far as I remember, and 101 pressure. The mass flow rate maybe was 20. Okay, and the unknown composition, the composition here I'm having a water, so the 100% water, and I'm pressing OK. So my stream is defined. I'm just want to make sure that the fluid package is natural gas is the second one. Okay, so this one water to mixer will be added here, so I can now delete this one, the previously added over here, which is water cutter and water. Press delete from the keyboard. Okay, and I want to delete the 3 items, the water, the cutter, and the water from the cutter. Okay, and now it's I can open the mixer over here, go to the inlet streams and choose water to mixer. So now I have the feed inlet. The red here names that I'm required to add a product stream. The outlet will be maybe feed with water, and the feed with water will be following the same fluid package, which is natural gas. Okay, if we look at the parameters over here, I'll find out that we have 2 options. Automatic pressure assignment, so the pressure could be equalize all or set the outlet to the lowest inlet. What does this mean? I have the outlet here, which is the feed, and the feed here, the pressure is coming from these 2. I have the option to set the outlet here to the minimum, which is 1.1. This pressure of the water to mixer is less than the natural gas phase. So in the parameter, if you check, you have set the outlet to the lowest inlet. So I have 2 streams, one at the pressure of 10 and one of the pressure of 20 psi. If I choose set outlet to the lowest, it will choose 10 psi. Okay, the second option is equalize all. If I choose this one, I will have an error here. Okay, because what? Because of what? Okay, let me set again to the lowest and make sure that always the solver, after any error appearing, make sure that the solver is active to solve your flow sheet. Okay, what does equalize all mean? If I have an inlet stream and this one, the pressure is not defined, and I set equalize all, it will make all the streams to this pressure, which is 1.3. Okay, so if I take this one and I delete 101 and go to the design parameters and I choose equalize all, what will happen? If I go to the worksheet again for the results, all will be equalized. So this is really important, because during the steady state simulation you can choose to equalize all, make the pressure of one stream the pressure of the other stream and the exit, or for the steady state you can set the outlet to the lowest. We have one with the low pressure, one with the high pressure. We are going to choose the one with the low pressure to be our exit pressure. But during the simulation in the dynamic state, if we are dealing with the dynamic state, you must equalize all, because this is what happened in real life. If I have a separator with an inlet pressure of 100 psi, this pressure or high pressure separator will be operating as the pressure of the inlet, which will lead to a pressure of the exit stream to be equal to, which means equalize all. So now if I have we have now 2 options, so I'm going again to delete. Okay, so because I have chosen equalize all, back to set to the lowest, and here I am having this one to be 101, and it will be solved because it is set to the lowest. This is important to understand. So for the mixer, if you are working in steady state, you can equalize all or set your outlet to the lowest inlet. If you are dealing with dynamic, you must equalize all. Okay, for the user variables and nodes, this is usually you can add here any nodes that you want to add from the user variables and also the nodes. For the rating, here we have another section most of the time, if we are dealing with a steady state or the dynamic state, we don't add information for the nozzle. Okay, choosing that your mixer is running equalize all is enough for your equipment to run as a dynamic. Okay, but what does the nozzle mean? Okay, we are going to talk about this one in our next video.